Hello and welcome to Lesson 6. This is Part 3 in Unit 1 Linear Systems in our Grade 10 academic math class. We're working on solving linear systems and choosing either substitution or elimination. So far we've chosen substitution when we have isolated variables. We've chosen elimination when it's not easy or convenient to isolate one of our variables with a coefficient of 1. The third example was another one similar to the first one where we already had an isolated x. No problem. Let's move on to D and see if substitution or elimination is the right choice here. So here we have fractions. Immediately I'm thinking this has got to be elimination because I don't really want to be substituting fractions, and unless you're super comfortable with fractions, then by all means give it a go. But I think here in general our best first step is to clear these fractions, and then maybe we'll have a better idea as to what the solution should be. So I'm going to multiply all three terms in this equation by a value to remove the fractionness of it. I have a 3 and I have a 4 as my denominators. That means that I'm going to multiply every term by 12. Similarly, in the second equation, I'm going to multiply all three terms by something to clear their fractionness. They have a 3 and a 2, so we're going to multiply that entire equation by 6. So I'm going to do a rewrite step here that might look a little bit long, but I just want to make sure that we can see that we're multiplying every single term by 12. So x over 3 plus 12 over 1 times y over 4 equals 12 over 1 times 2 over 1. So there's our, oh, I should label these. That's equation 1. That's equation 2. And let's do the same thing for the second equation. So we have 6 over 1 times 2x over 3 minus 6 over 1 times y over 2 equals 0 over 1 times 6 over 1. So there we go. Let's do a little reducing before we get to the multiplication here to keep our numbers manageable. So I'm going to divide both the numerator here and the denominator by 3, and that's going to result in a 4. I'm going to do this something similar here. I'm going to divide both the numerator and the denominator by 4. That's going to give me 1 in the denominator and 3 in the numerator, and over here no reducing to do. So let's rewrite that first equation. How's about? So we've got 4 times the x. The denominators are both 1, so we don't need to rewrite those. So we have 4x's plus 3y's equals 24. All right, let's do some reducing in that second equation before we write it out. So same thing here. I'm going to divide both the numerator and the denominator by 3. We have 1. We have 2. Whoops, 2. And over here, we're going to divide both the numerator and the denominator by 2. That gives us 1. And 3, and no reducing to do in the second one. So let's get equation number 2 done here. We have a 2 times a 2x, that's going to give us 4x's. And we have a 3 times a y, so that's going to be minus 3y, equals 0 times 6, of course, is going to be 0. So that's our equation 1 and 2. Now looking at this, it's perfectly set up to do elimination, as we thought it might. So let's do some eliminating now. And we have 4x and a 4x. We are going to subtract 4x minus 4x is no x's, so the x's have been eliminated. And we have 3 minus 3, which is 3y plus 3y, which is going to give us 6y's equals, and 24 minus 0 is going to be 24. Let's isolate y by dividing both sides by 6. Y then is equal to 4. And now let's do a substitution. We are going to sub y equals 4 into, now again, I typically recommend substituting into one of the original equations. In this case, however, just because they're kind of gross looking, let's use the newly defractioned either 1 or 2, and at this point it doesn't really matter. I guess 2 probably looks a little bit easier because there's a 0 in it. So let's substitute y equals 4 into 2. So number 2 is 4x minus 3 times 4 equals 0. And let's do some math. So we have 4x minus 12 equals 0. Let's transpose negative 12 to the other side by adding 12 to both sides. That's going to give us 4x equals 12. And we are going to isolate x by dividing both sides by its coefficient, which is 4, giving us x equal to 3. So despite looking kind of gross, it kind of worked out pretty nice. So we would say then, therefore, the solution is 3 and I think it was 4. There we go. The solution is 3, 4. There's our therefore statement. There is our lesson. So hopefully this is making sense. Again, it's mostly just practice for substitution and elimination. A little bit of guidance so you're not setting yourself up. Setting yourself up for a whole bunch of headaches is always a good thing. So good luck with the homework. As always, if you need to get a hold of me, reach out via email, reach out in our online video chat that's open every day, as well as coming to see me in person if you happen to be in class. So that's it. Good luck with the homework, and we'll see you in lesson number 7.